Lesson 7.4. Okay. Properties of logarithms. So 7.3, as I previously was trying to say, we learned how to go the connection between a logarithm and an exponential equation. Now 7.4, we learned properties of what we can and can't do with logs and how that can help us. Eventually we'll use these properties to solve equations with logarithms. I think that comes up in 7.5. Right now it's just, okay, what can we and can't we do? So there are 4 properties up here that you're going to want to be familiar with. The product property. So the product property says if you have a log of any base with multiplication inside, that log can be that single log can be broken up into 2 separate logs that are being added. Or reverse, if you have 2 logs being added that have the same base, you can take those 2 logs being added and you can put them together into 1 log where the insides then are multiplied. So you've got to keep in mind that multiplication goes with addition. So for instance, the log base 6 of 8x. Well, 8x is 8 times x. I don't know if that made it any better or not, but it's 8 times x, right? So I can take that and make it log base 6 of 8 plus log base 6 of x because it was 8 times x. So that's your product property. We've also got a quotient property. The quotient property connects division with subtraction. So log base b of m divided by n says, okay, if you've got division within a log, it can be rewritten as 2 logs being subtracted. Or 2 logs being subtracted can be rewritten as 1 log where the insides are divided. The example, log base 2 of 8/3. Well, that's 8 divided by 3. That can become log of 8 minus log of 3. Notice the base 2 kept the same. Okay? Yes?
Does the top one always have to be the first one? So, like, does the m always have to be the m in the thingy, or can it be interchangeable? So, like, could it be log base 2 of 3 minus log base 2 of 8, or does it have to be log base 2 of 8 minus log base 2 of 3?
So in division, the subtraction has to stay in the same order.
Okay.
Like you have to do top minus bottom. With multiplication, it won't matter because you can switch multiplication, you can switch addition. Division and subtraction does matter. Okay? Okay, power property. Power property says if I have a power, so an exponent, on the inside of the log, that power can be moved out front to be a coefficient. So it'd be a number in front. So log base b of m raised to the power of n, you can take that n, move it out front, and make it n times log base b of n. For example, log base 2 of x squared. This power of 2 can move out front and become 2 log base 2 of x. So that's a power property. These all have ways and reasons we use them. And then lastly, the identity property. And the identity property has a couple good uses. We use it a lot when simplifying. Log base b of b equals 1. So that's saying if the base of your log and the inside of your log, so in this case the b's are the same, that log will equal 1. So log base 2 of 2 equals 1. Log base 5 of 5 equals 1. Now the alteration on this is if you have something like log base 2 of 8, well, keep in mind, 8, that's on our gold paper there, right, with the powers. 8 is also 2 to the third. And so to notice right here, those 2's match. If you have log base 2 of 2 to the third, that one equals 3. So basically the shortcut is it equals whatever the exponent is. Because like on the basic identity, log base 2 of 2, there's an invisible power of 1. And so as long as my base and my inside base are the same, it's always going to equal the exponent. That's our identity property. So these are all 4 properties we're going to use as we go through this lesson. And as I said, they'll carry into the next lesson, actually the next 2 lessons, but the next one for sure when we're solving equations. Okay, so one way we're going to use these. Example 1. What is each expression written as a single log? So you see multiple logs being either added or subtracted. We want to take these logs and write them as a single log. So, obviously using the properties up top. Log base 4 of 32 minus log base 4 of 2. Thoughts on what we can do here using our properties? Okay, quotient property. We see subtraction. Subtraction of 2 logs, as long as they have the same base, can be rewritten as 1 log. So I'm going to rewrite this as log base 4. And then what do I do with those numbers?
32.
Yeah, we're going to divide them. We're going to put it as 32 over 2. Now, you should always do any simplifying you can. Math Excel definitely will not let you leave something like this. They would be very unhappy. So, the obvious, what is 32 divided by 2? So, log base 4 of 16, because 32 divided by 2 is 16. So that was an example of how to use the quotient property. Now, what if I say we can technically go a little farther with this?
Yeah, you can do 4 squared and the 4's cancel and just be 2.
Okay, so here's the deal. This can simplify a little farther, and I don't remember exactly what's in Math Excel, but something like this, they would probably say it's not simplified. I have a base 4 here. Can 16 be rewritten with a base 4?
Yes.
Yeah.
According to my gold paper, 16 is the same as,
2/4.
I don't want to go 2 to the 4th. I want to say 4 squared. And I'm not disagreeing with 2 to the 4th, but here's the deal. What's the base here? The base is 4. So we want to work for that same base. So I could rewrite this as log base 4 of 4 squared. Equivalent. I haven't changed anything. It's still equivalent. But our identity property here says if my base of 4 and the base of 4 on the inside are the same, it's equal to the exponent of 2. So that actually just becomes 2. Questions on that one? Make sense? I don't know that this is difficult today. It's just different. I think that's a good description. You know, it's different from what we're used to doing. Okay, let's try B. 6 log of base 2 of x plus 5 log base 2 of y. Thoughts?
Product property.
Yeah.
Okay, so he asked about product property. I'm going to say yes, but
There's also
not yet.
power. You add it.
Okay, so here's what I'm going to say. We will use the product property, but we're not allowed to use the product property yet because these logs have numbers in front of them. So we can't take 2 logs that have numbers in front of them and put them together as 1 log.
You gotta do the power property.
We got to do the power property first, which the power property says a number out in front of the log can be moved where? To the back of the log as a power, or as an exponent. So 6 is going to move and be the power on the x. 5 is going to move and be the power on the y. So my first step I can do is I can rewrite this as log base 2 of x to the 6th plus log base 2 of y to the 5th. So that's using our power property. Now, we have 2 logs being added. They have the same base, correct? So So what do we do? Well, you mentioned the product property earlier. What's the product property say? Two logs being added can be rewritten as one log where the insides are multiplied. So I can rewrite this as log base 2 of x to the 6th times y to the 5th, which, when I say x to the 6th times y to the 5th, I would encourage you to put that in parentheses. The parentheses indicate that they are both part of this log. If we don't have the parentheses, we technically could question, is that y really a part of this log, or is it just being multiplied after the fact? And then on this one, this is as far as you can go. My base of 2 does not match any, I have base of x and base of y, so those don't match. So we're done right there. Okay. Let's try C. Log base 4 of 5x plus log base 4 of 3x. What rule can I use from above?
Product again.
Product again? I have two logs being added, yes. Do they have the same base? Yes, so I can rewrite them as one log. Did I have any numbers out front I needed to worry about this time?
No.
No, they're both just logs. So we don't have to worry about that power property. We're just going to put this together. So as I rewrite this, it's log base 4. And what are my insides? 5x times 3x. Notice I put parentheses to make sure the whole thing is included so we don't have to question. Now, I can guarantee Math Excel would want you to go one step further. Yeah, what is 5x times 3x? 15x squared. So I'm going to rewrite this as log base 4 of 15x to the second. And I guess I say Math Excel wants you to go one step farther. I want you to go one step farther. I don't want you to stop and leave it as log of 5x times 3x. I want you to acknowledge that, oh, hey, I know 5x times 3x is 15x to the second. Okay, D. 2 log base 4 of 6 minus log base 4 of 9.
Can you take just one number? Or then you have to take it from there?
Yeah, we can use the, you're talking about the power property, right? Yeah, we can use the power property on just one. And we're going to have to here. Because here's what I'm going to say. I can't put these together as one log as long as either of them have a number out front. So power property says this 2 is going to go over here and become a power. So for starters, I'm going to say log base 4 of 6 squared minus log base 4 of 9. What do you know about 6 squared?
It's 36.
It's 36. Is that good to know?
Yeah.
Yeah, in fact, I'm going to go ahead and rewrite that. Log base 4 of 36 minus log base 4 of 9. Am I done?
No.
No. I'm not down to one single logarithm yet, am I? 2 logs being subtracted. Put them together as one log, where the insides are divided. So log base 4 of 36 over 9.
Can't we simplify it?
Oh, can we simplify it?
Yes.
3 over 1.
Does 36 divide by 9?
Yeah.
Yeah, what is 36 divided by 9?
3.
4.
4.
So now it becomes log base 4 of 4. Should I keep going? If you can. What do you notice about the 4s? They're the same. So that brings in our identity property. If those 4s match, it's going to be equal to technically whatever the exponent is. What's the exponent on this 4?
1.
An invisible 1. So this is equal to 1.
Is it always like that? It'll always be 1 if it's like log base 4, so 4.
Yes, if these 4s match and there's no exponent here, it's a 1. Unlike this first one, though, the 4s match, but there's an exponent of 2, so my answer was 2. It's always whatever that exponent is. Okay, we got a hang of how to take multiple logs and reduce them to a single log. And again, this works as long as the bases match. And guess what? The bases are going to match for the most part, right? Like, that's the design. Now, that is what I would say was consolidating logs. Taking logs, writing them as 1. Now, we get to do the opposite. It is, I guess the word for the last one I think they sometimes say is condensing. This one, they say expanding. Taking the single log and expanding it into multiple logs. So basically, those same rules we were just using, we're going to use them in the opposite direction. So as you look at log of 4x over y, what's the first piece that comes to mind?
Log base 10.
Okay, it is log base 10. There's no base written, right? Which that just means as we write our answer, we don't have to write a base. What do you see happening within that log?
Dividing.
There's division in the log. So division in the log means I can rewrite it as 2 logs being subtracted. Okay, so let's start there. Log of 4x over y, I'm going to rewrite as log of 4x minus log of y. I put parentheses around the 4x, just trying to be appropriate there.
It looks like you put 1.
Now, I'm going to claim we're not done. What's another property I could use here? Laura?
Would the X go in the front? Like power property?
No, it's not a power, so it's not the power property. What is happening between the 4 and the x?
They're being multiplied.
So they're being multiplied. This is 4 times x. What do you know about if the insides are being multiplied? We can separate it into 2 logs being added, right? Here there was division, so we first took that and separated into 2 logs being subtracted. Now there's multiplication. Now we're going to take this piece and break it up into 2 logs being added. So now I'm going to say log of 4
And then log plus log of x.
plus log of x, and still, don't forget,
Minus log.
minus log of y. Now, I could go one of 2 ways here. I could say we're done. And this is an optional option for an answer. I could say we need to go 1 step more. Now, things like log of y and log of x, they're not going any farther, are they? It's just a y, it's just an x, there's nothing else to do. So that takes me back to the 4. What do we know about the number 4? Okay. This is where our gold paper, we're not using it as much this lesson, but it's still helpful to think about. Log of 4 is also log of 2 squared. With log of 2 squared. Now, it doesn't match, the 2 and the base don't match, so I can't do anything fancy there. However, what can I do with that power of 2? The power property says I could move this outside, and I could say that this is 2 log of 2, and then still plus log of x, and still minus log of y. This could be an appropriate final answer, or that could be an appropriate final answer. I don't remember what kind of issues you run into on Math Excel, but be aware, right? I'm not saying you necessarily run into this issue, I'm just saying be aware. Questions on that one? Okay. And I can see from my front row, some of you are seeing the issue we're going to have is, notice I'm kind of running into B already, aren't I? We have a lot of examples here. So as I look at my notes, what I'm going to tell you is I'm going to do is I'm going to kind of alternate. Like there's A for B. I'm basically going to put B down here and kind of put B down here. And that way then C can be kind of up under here. And I'll do that. Does that make sense? So I have A, B, C, D, E. So if you need a way to set your notes up and you're like, I am running into the next example, because some of these are long. It gets worse by the time you get to the end. So that's my setup. You do what you want to do. Okay? Sorry, I'm watching several of you erase like, oh no, I'm running out of room. Okay, guys, example B. Log base 9 of x to the 4th over 729. Start with the obvious. What's the obvious? Okay. We see division. So we're going to take one log with division and rewrite it as 2 logs being subtracted. Log base 9 of x to the 4th minus log base 9 of 729. Okay. What else? Okay. X to the 4th. That 4 can be written out front. So 4 log base 9 of x. That is always expected when you are expanding logarithms. They always expect you to take the powers and put them out front as coefficients, so put them out front. Does the number 729 mean anything to you?
9 squared. No, please.
Okay. Here's my suggestion. Have the gold paper beside you as you work through this. Because 729, I don't necessarily expect it to mean anything to you. But the gold paper is going to show you it does mean something to you here. Do a quick scan. And what's really important is, especially if 729 could be rewritten with a base of 9, that's going to be really hugely important because that's really going to affect our answer. What do you notice? Okay, 729 is 9 to the 3rd. Ah, I forgot. It's also 3 to the 6th. Now, so it's on here twice. Which one's important in this situation?
9
to the 3rd because my log is log base 9, right? So those gold papers, not using them every problem, but I would definitely rewrite this as log base 9 of 9 to the 3rd. So, I'm going to say there's one more step I can do. I wouldn't even think power property. What's the identity property tell me? If those 9s match, this log is equal to, well, the power, which is 3. So I'm going to rewrite this. It's still 4 times log base 9 of x minus 3. Hopefully you can read that. That 3 ended up right in the middle of a little square. Okay. See? Log base 3 of 250 over 37. Okay, what's the obvious? I expect everyone can get the obvious at this point.
Subtraction.
We see division, so we're going to rewrite it with subtraction. So I'm going to say this is log base 3 of 250 minus log base 3 of 37. I would like to think that's the obvious at this point. Now, we're just working with numbers here. So it really comes down to if there's any powers we can do anything with. It would be so much better if that was a 27, wasn't it? But 37, and as I think of 37, 37 is what I would call a prime number, which means the only way you can multiply to get 37 is 1 and 37. So there's not going to be a thing I can do with 37. Now, 250. Is it a power of 3? No. And so, I mean, I guess one option might be that you could technically stop here. Okay, I get that. But I want to show you what the book did on this type of problem. So 250, you're not going to find it on your gold paper. But you're going to find something that goes into 250 on your gold paper. So scan your gold paper, and 250 is divisible by 125, right? So an option, and again, this is kind of more of a, I don't know, a trickier problem, okay? I want you guys happy with the basics, but I want to show you kind of the extension here. So I'm going to take this log base 3 of 50, and it's going to be, what is 250? 2 times 125. Well, think about where I'm going with this. Multiplication inside a log can be rewritten as 2 logs being added. So I can rewrite this as log base 3 of 2 plus log base 3 of 125. Now, and I guess officially I should probably, I'm probably going to lose it if I don't. What do we still have tagging along on this problem? Log base 3 of 37. Don't lose it. Don't forget about it. So easy to do. We picked 125 because it's on that gold paper. What is 125 on your gold paper? 5 to the third. So I can rewrite that one as 5 to the third. So only somewhat helpful here because did my base 3 end up matching the base of the problem? No. So the only last step I can do is I can take the power of 3 and move it to the front. So don't forget, we still have log base 3 of 2 plus, moving that 3 out front, 3 times log base 3 of 5 plus, if you didn't lose it, log base 3 of 37. Again, it's a fancier example, but I'm trying to get you guys to make those number connections, trying to get you to see, okay, how can these various numbers on the gold paper help me? What I'm going to say, I'm going to stop here, take a quick look at D, before you pack up real quick and see if you can make any progress with D, and that's where we'll start tomorrow. So take a quick look there, see if you can come up with any thoughts, write those down, and we'll pick up there tomorrow. And make sure tomorrow on the backside we do have to have the calc there, so make sure you have your calc theres with you tomorrow.